Hello, everyone. Thank you for coming to this panel on privacy, I think, which is the next really cool frontier. I'll quickly introduce myself, and then we'll have some introductions from Awa and Alex. Actually, it's really nice to see some familiar faces. I'd been leading the protocols team at Steakfish, and then where I knew Awa, and then Alex, my grad school advisor when I was studying cryptography and distributed systems, was also the co-author of the Aleo paper. So it's a very small world. So maybe we could go down the line. Awa, maybe you could describe a bit about your background, how you came to Namada, and then maybe as well for you, Alex.
Hi everyone, my name is Awa. I'm one of the co-founders of Namada and Anoma. I had a pretty non-standard intro to the space compared to many other founders. Actually, my first job in the space was at Chainalysis, and I was working there basically on applying ML to break privacy on Bitcoin.
Hey everyone, it's a pleasure to be here. I'm Alex. I'm the CEO of Aleo. I think it's standard to have a non-standard background in a crypto, and I guess I also have a non-standard one. But I spent the first 10 years of my career in the U.S. Army, and I actually got introduced to Bitcoin working in the Middle East with folks that we were training at the time. These were Syrian rebels that were fighting the Assad regime, and I was introduced to Bitcoin through that experience. Finished my Army career, went to grad school, was introduced to some of the more deeply technical cryptographic concepts that I think a lot of people are integrating today into the space. And one of those concepts is zero-knowledge cryptography, which inspired me. I ended up taking a job in venture capital right after grad school, and then ultimately found my way to Aleo, which is a new ZK layer 1.
Great. Maybe we won't get into the deep technicals first, but maybe if you guys can describe TLDR versions of maybe Anoma and Namada, and then Aleo, and then we can get into the dirty weeds. Yeah.
I'll focus on Namada actually. So the TLDR of Namada is basically if you're a multi-chain user, as in you hold assets on Ethereum, fungible, non-fungible assets, and you interact with different chains and applications like Osmosis and Cosmos, what do you use for privacy? And the short answer to that is that nowadays there are very limited decentralized systems that allow you to get privacy, Zcash, Tornado Cash, and a few applications in Ethereum. And they're so limited in the privacy guarantees that in practice they don't provide enough privacy. So the ironic reality of today with privacy is that every crypto user actually uses centralized exchanges for privacy. And that is because when you do that, when you make a payment from an exchange, when you look at Block Explorer, all you see is that it comes from Binance, Kraken, and so on. So it breaks the linkability between your transaction history and your identity. So this is really sad because the entire purpose of this space was to decentralize, right? To remove intermediaries and bring in better properties like privacy. And somehow with the lack of privacy in the existing systems, we're going back to square one, which is actually the lack of privacy is becoming a centralization factor. So with that, we built Namada. And then the main purpose of Namada is to bring in privacy in a way that we haven't seen before. So it's designed to bring privacy in a composable way. And what that means is for users that we assume that users want to continue using the assets they currently hold. So let's see USDC, USDT on Ethereum, ETH, they're NFTs on those systems. And they also like atoms, use DEXs like Osmosis, DYDX. And what we give them is basically the ability to continue doing so and holding these assets, but privately. That is a fundamental new design of how we bring in privacy, as opposed to how new systems require you to historically, basically to want a privacy, you can have to buy into monetary policy, go to a specific platform or application. And the other main advantage of composable privacy is that applications and base layers like Ethereum do not have to make any changes to support privacy.
In Aleo, I think the TLDR is Ethereum and Zcash had a baby, and that would be Aleo. And it's a little bit of a kitschy way to describe it, but I actually do think and am excited about Aleo because it's a synthesis of many ideas that have come before in the space, right? Like for example, this is the zero knowledge cryptography that Zcash pioneered, and this idea of smart contracts that really inspired Ethereum now almost 10 years ago. So it's a synthesis of those two ideas. It's also a synthesis of the two, I guess, most prominent consensus protocols, right? Proof of work and proof of stake. In Aleo, we have a proof of work mechanism around incentivizing provers to generate zero knowledge proofs for the protocol in order to bootstrap an ecosystem which could then serve to help enable transactions for regular users. But we're also we're building a new proof of stake blockchain, which will have starting in a couple weeks, 55 validators from around the world who will be participating in that using the latest and greatest in proof of stake bull shark narwhal consensus. So it's a synthesis at that level. And then lastly, it's a synthesis of permissionlessness with privacy, right? And I think that's something that has never been done in the space before. I think there are some, there's some protocols where you can achieve privacy, like, actually, I guess maybe the simplest way to achieve privacy is to send your money to an exchange and then send it out, if we want to call that a protocol. But you've never been able to do that in a fully permissionless way. And this is something that we at Aleo are very passionate about. Is permissionlessness is what defines blockchains. It's what makes them special, I think, compared to other types of technical architectures. And so, yeah. So in short, Aleo is a new ZK layer 1 hybrid proof of stake, proof of work blockchain that uses zero knowledge cryptography in a permissionless setting to enable new types of applications in Web3 that have never been possible before.
I'd really like to get into the infrastructure differences between Namada and Aleo, but before we get there, I'm curious as to your opinions or thoughts about why it has taken so long for our space, maybe to get the type of what we had hoped to see is this sort of mass adoption for each of your protocols, to have this types of privacy versus what we had with like very transparent blockchains. Maybe we were using those transparent blockchains incorrectly before, and people were just using it in a way that was not aiding privacy, and then why do we have it today, and why is it taking so long?
So from my point of view, there are two things. So the main thing is that we needed some time to develop a technology to make this possible. So the advances in cryptography, specifically zero knowledge proofs, have actually improved a lot in the last year. So it's been around for a while in research. It's been around for a while since Zcash deployed first. But there have been actually optimizations and improvements that made it possible to create more accessible UXs around these applications. For example, running zero knowledge or creating zero knowledge proofs and running these applications in browser. And that is actually very important to make it accessible for any user in crypto, not just for cypherpunks. There's another aspect to it, which is the multi-chain has developed a lot more. Before, we came from like more the maximalist point of view, right? The average user will hold just Bitcoin, just ETH, maybe a few other altcoins. But nowadays, the user is multi-chain, so they will hold different things across different chains with different consensus and security domains. And the thing that we have seen greatly evolve in the last recent years is interoperability protocols. So IBC is a great standard that is non-permission and then is completely neutral. We've seen a lot more breach designs, so particularly a lot of them sadly go more to like the trusted, semi-trusted model, which I don't think is a great design, especially for users. But like, at least from our side, we are pushing more for the direction for bridging, where it's a lot more about providing the best trust guarantees for the users and not adding centralizing factors or trust assumptions to it. So I think that's another aspect of why nowadays it is actually possible. I was like a few years ago, making real privacy access for users was like harder, but today is not rocket science anymore. It's a matter of prioritization.
Yeah, and I'll build on that. So I think Awa mentioned some important UX reasons why this hasn't been adopted. I'll say something maybe a little bit controversial, but that I truly believe in. I don't think blockchain or cryptocurrencies have come close to reaching their potential precisely because there is no element of privacy. Like there's no way to shield what you do. Everything is fully open and transparent by default, right? And I think that's one of the big reasons that the space has been held back. Because if you think about the financial system, many times we talk about as something we're trying to replace, the user experience of the financial system. Like if I send Daniel a bank wire, all of you in the audience don't know that, right? Like Daniel knows that he received it, he knows the amount, I know that I sent it, but the world doesn't see that, right? I think some people use Venmo, right? But commercial banks, when they're settling between each other at the end of the day, don't use Venmo for this exact reason, right? There's a lot of reasons why we would like our financial lives to at least to have some control over who can see what, to have some control over the visibility of it, right? So I think in some ways that the lack of that has been what has held back the space from seeing adoption that I think it otherwise would have already seen. So that's one thing that I think has really held the space back. The one other thing I'll say is I think too often we think of these systems as just standalone, independent. But in the reality, these are systems just like the web, are decentralized networks, right? And our day-to-day, I mean, how many hours a day do we all spend on our phones or on a web app or something like that? The fact that we've kind of architected things to be separate, like there's a whole separate user flow, there's a whole separate app and everything. I think that's also, from a UX perspective, that's something else I would mention. That's something, for us at Aleo in particular, a goal that motivates us is a world in which you can run a node that's verifying a bunch of blockchain state in your browser transparently. Your interactions on a web page are zero knowledge proofs that you are generating on your client side device. And the whole thing is transparent to you, but it's a fundamentally more secure and more personal web experience. And the web has been extended in that case to include financial transactions instead of just the flow of information.
Do you have something to say?
Actually, just wanted to remark on the first part of everything that Alex said, which is what people are not realizing today is that because we lack privacy in decentralized systems, it's actually becoming a centralization force. As people are actually using centralized services in crypto to achieve privacy. And this is because public blockchains nowadays provide actually worse privacy than the financial system than Web 2. So yeah. Just want to remark on that.
I'll admit that was a bit of a leading question because I think one of the main differences between Namada and then Aleo is that you have this default interoperability from the get-go, and then Aleo is a standalone. You have your own domain-specific language. And then we are talking about how there's been this sort of evolution from, let's say, existing L1s or app chains that have maybe not the ideal set of properties that we would like to have, like privacy. So is this now right? We're talking about an evolution of these new chains that you guys have been building. So if you are better than Ethereum at default or whatever, so interoperability, then you are interacting with other, let's say, blockchains that don't have the satisfactory type of properties that you would like, versus maybe I wouldn't say Aleo is siloed or isolated necessarily, but you guys probably have your very strong reasons for not being also interoperable at get-go, but you have your own sort of very strong opinions of how you need to develop your ecosystems. So yeah, I'd be curious as to the rationale behind at your default interoperability states, and then how you guys see yourselves as an evolution in terms of connecting or not connecting with other older ecosystems. Yeah.
So there are two kind of design directions that we are taking, right? In the case of Namada, what we want to prioritize is that let people continue doing what they're currently doing, but privately, adding the least friction possible to the user and the least friction possible to these applications, these infrastructure layers that will require multi-year roadmaps to actually support privacy. So there's one direction that so far no other project that focuses on privacy has taken. And there's the other approach, which is let's make Ethereum but fully private, and bring in new applications that just provide better privacy by default. I think what's going to happen is that well, my assumption is that these systems will eventually end up interoperating. On one hand, I think there is a strong case for people will continue preferring to use, let's say, Uniswap. Like not that many applications in Ethereum that actually use, right? Like there's Uniswap, there's maybe OpenSea. In the customs world, there's maybe Osmosis. There's maybe DYDX in the future. But fundamentally, people want to prefer to continue using these applications. And then our approach is more about, okay, how do we let them do it, continue using them with privacy? This is not to say that there are no synergistic points between how Anoma approaches privacy and Aleo has approaches privacy. Actually, the thing that will bring the best privacy in multi-chain would be if we enable actually private bridges across systems. And it is even better if there are more systems that provide what we call the shielded sets, or anonymity sets. And with like more developments in research into interoperability protocols, that will allow us actually to connect the entire multi-chain into one big anonymity set. And that would be like the thing that will provide the best privacy, actually. We should actually pursue towards something like that. And really, if you look into crypto, into blockchains, there's just no privacy sets, right? So like, I think it would take a long time until different privacy approaches become competitive. I think for a long time it's going to be primarily going to benefit from collaborating and connecting.
Yeah, so I guess the question is kind of on the philosophy of like what motivated our design and why did we go one route versus another. I mean, look, there's the first obvious question is like, hey, there's a lot of layer ones out there. Why make another layer one? There's lots of other blockchains we've already heard. Like, what are you guys bringing to the table? And the motivation behind that, actually, in fact, Aleo was conceived initially. This is 4 years ago now, as a layer 2. But unfortunately, every layer 2. Well, what we found is, as a layer 2, you have to contend with all of the design decisions at layer 1, right? And it's not to say these are good or bad in some sense, but I guess in the sense that you're optimizing for a specific outcome, which in our case was a performant, permissionless, privacy-preserving system, that we found that the underlying architecture of Ethereum just wasn't built for that, right? Specifically, the privacy-preserving nature of it, right? And I won't get into technical details, but some of the cryptographic curve choices, et cetera, are just not. There's a significant performance penalty that you pay if you inherit that, right? And this is something that I think has actually affected a lot of the teams that are building ZK EVMs. In fact, last year I gave a talk at this conference, or I'm sorry, it was ETH Seoul. It was, is Aleo a ZK EVM? And spoiler alert, maybe, because the term ZK EVM is very, very wide and a little bit flexible. But I guess in all seriousness, the need to optimize performance to enable some of these new use cases, like privacy-preserving financial transactions. Like another one that I didn't mention that I'm really excited about is identity and a new form of authentication authorization that's privacy-preserving and permissionless that interoperates with the modern web. Like none of that would have been possible on Ethereum today. And Aleo, I'm very thankful to say we're 3 months away from launching mainnet, and I think we're going to be the first permissionless, privacy-preserving network where you can do all these things. And a lot of that is because we didn't have to work around an existing system. Now, what is the drawbacks of that? Well, the drawbacks of that are you don't get to inherit, an already existing developer ecosystem. But, I think interoperability is going to be inevitable in some form. What form will that take? I have no idea. I mean, honestly, I have opinions, but at the end of the day, what will determine it is, as Awa kind of hinted at, is like there will be users of applications. Those users of those applications will more or less define by their activity what the ultimate solution looks like. Their implicit preferences will drive what the underlying architecture looks like. And that's a good thing. We should all of us in this room who've been building, I've been in the space for 8 years. I'm sure many people in here have been in it longer. We should look forward to the day where the development of products in the space is being driven by users and driven by applications that users demand instead of building things that we think that they want. And that's really, I think, if we're getting to philosophy, the true philosophical motivation for us is to try and build something that enables a new capability that creates truly novel opportunities and applications that we believe, will be really interesting to end users, in crypto and outside of crypto.
I really want to get into what I'd probably talking about the different infrastructure stacks that both Namada and Aleo use. And I think personally, I think like one of the most exciting things has been like the infrastructure ecosystems that have brought about a lot of the resurgence of interest both from VC, et cetera, right? Because ZK has been around since the 80s, and then people had to like barely scrape together NSF grants to get money to do research. But now everyone and their mother wants to put money into like ZK stuff and stuff. But can you talk a bit about like the ZK infrastructure that Namada makes use of, and then maybe Aleo as well? Yeah.
So with the zero knowledge part of Namada, enables something that you cannot achieve with existing ZK systems, which is it allows all assets to share one anonymity set. This is what we call the multi-asset Shiller pool. And this is also in alignment with, like, we assume that people want to continue holding the assets that they're currently holding and using. So the problem with how we have approached privacy in the decentralized system with privacy coins, with applications on Ethereum, is that actually what's happening is that instead of having one anonymity set, because all users actually want privacy, right? That's what makes them, what they have in common. Instead, with the design of existing privacy, we have actually been fragmenting the privacy sets of entire crypto. And then the smaller the privacy sets actually leads to less privacy and worse privacy guarantees in practice for the user. It just makes it trivial, more easier for chain analysts to break the privacy. So ideally what you want is like all crypto to share one big anonymity set. The larger it is, the stronger the privacy guarantees. So the main component of zero knowledge cryptography with Namada is this cryptography that allows you to create one unified Shiller set. And actually, that breaks away, like, that breaks the limits of how large it can be because of this, like, all assets could share one set. But even if you bring it to, like, let's assume in the future where more fiat currencies actually turn digital and then become cryptocurrencies, the beauty of this is that there's a limitation in fiat currencies, which is the size of the anonymity set of the US dollar is as much US dollars is in circulation. Obviously, we're not so concerned because the volume there is massive, right, compared to crypto. But in the future, if all the US dollars, all the fiat currencies were to become digital, and we were to use the MASP on Namada, actually we will be able to create even a larger anonymity set in the entire world that we can actually create currently with fiat. So that's just like an interesting idea that comes from this cryptography.
Yeah, the first thing I would say is, look, in case it's not obvious to everyone in this room, zero-knowledge cryptography is going to change the internet, period. It's probably the single most revolutionary cryptographic technology that we've seen in our time. It will fundamentally change the internet. I mean, I work hard, and I know Awa works hard every day to make sure that our companies are part of that story. But like this idea of being able to prove something without revealing why it's true has no physical analog. I mean, it's why it's often compared to magic. I mean, this can be applied in so many different and cool ways. And that's why we really took the approach of, like, again, building a ZK virtual machine or a ZK VM, kind of a new layer one that had a ZK VM built on top, so that developers, through our programming language, our domain-specific language, Leo, could write applications that took advantage of this power that exists, that's kind of inherent in this new cryptographic technique. And I think there's lots of examples. Like one example, I mentioned identity a minute ago. Being able to authenticate online about based on some personal facts about yourself without having to reveal those facts directly to the server, right? A simple use case, for example, is age verification. Like, there's not really a solution for age verification online today unless you trust you have a single trusted third party, right? And for a lot of reasons, I think many governments and regulatory bodies are skeptical to put the responsibility of a huge database of people's personal information online or with a specific tech company, right? So this is a new capability that this technology can enable. That doesn't just solve a problem for Web3, it solves a problem for Web2. And I think you'll see these ideas that get applied, and you'll see more and more overlap. And another really cool thing about ZK is that, at least in the model of Aleo, and it can apply elsewhere, but when you have a model where you're executing programs off-chain and then verifying them on-chain, you no longer have the limitation of gas. And for those of you who aren't familiar with gas, the whole point of gas is to make sure that people can't just spam the chain with very intensive transactions, and that basically cause everything to halt, right? And so this is why like you could never really do any kind of serious machine learning model on Ethereum, even if you wanted to, right? Whereas in the model of Aleo, where you have off-chain computation, you could run a machine learning model for 1 million years, submit the transaction at the end that says, hey, I trained this model according to these parameters or whatever, and that would be a valid transaction just like any other transaction that you maybe was just a transfer. And so I think it opens up a door to these new possibilities. So fundamentally, I think this paradigm is going to be revolutionary.
I did want to remark on like the power of zero-knowledge proofs is really what we're trying to do, what is bringing to the systems is giving back the power to the users to control basically what data is disclosed and shared with whom at all points, right? And this is bringing just a different kind of like properties to the systems that can be a more resilient set of properties for infrastructure than existing systems. So I think that is like the most powerful part about zero-knowledge proof is giving users back the control over the data.
Maybe 2 minutes each. What are you most excited about for like realizing the ideal of each of your projects?
I really want to test how many more applications will start spawning as like, it can just be interfaces, just by the simple fact that we enable multi-asset privacy. Because actually there are a lot of decentralized applications that solely rely on the limited programmability of just payments, let's say. But I think the thing that hasn't been tested is that if we're able to create one infrastructure tool and allow the user to use whatever they want to pay, currency that they want to pay with, I kind of want to, with privacy, of course, it's like this is a financial system, I kind of want to see if that will unleash way more adoption in crypto.
Yeah, I think I have two, one infrastructure related, one application related. The infrastructure side, I mean, for me, I'm really excited to see, like I mentioned a second ago, how ZK is going to change the web. And I think it's going to spawn an entirely new category of infrastructure providers called provers, right? And this, provers, you could be yourself a prover, or, you could give someone a transaction to prove on your behalf, or multiple parties, to prove, and have them prove on your behalf. So I think you're going to have an entirely new category of infrastructure around proving that we haven't seen at all before, but I think is going to be a very important part of the future. I'm very excited for that because of the way we built our protocol kind of incentivizes that, and I'm looking forward to seeing what happens there. The second piece on the application side, look, I'm excited about the applications that people are going to build, but one thing we didn't get to touch on this panel, but I think is an important topic whenever we're talking about privacy, is compliance. And I think a lot of people in the privacy space or in the ZK space kind of like lean away from people in government, and they kind of would be preferred to be not known. I actually am excited to lean into, engaging with, big financial institutions, governments, and educate them on how this technology actually is a better compliance tool than exists today, right? If you can imagine like something like this, basically being able to mimic the cash, right, in the sense that it's untraceable. You can actually encode via whatever you're proving some kind of compliance check, right? So you can basically build a form of smart cash, and therefore you can actually make the job of regulators a little bit easier, right? Because in effect, every transaction that goes on in a given system is correct by construction, right? You can say like, hey, before you spend this $1, you need to prove that like, hey, you're not on an OFAC blacklist, and B, you ate your Wheaties this morning or something, whatever, right? Like whatever rule you want to have, you can encode, right? And so this is kind of the power of smart contracts, but the power of smart contracts coupled with the power of ZK gives you the best of both worlds, right? You can have a system where regulation can be applied, but also consumers are protected and their information is protected. And so I think the potential to have your cake and eat it too, you very rarely do you get these opportunities for that, but I think uniquely this technology, just by its nature, can enable it.
Thank you so much, guys.
Thanks.
Thanks, everybody.
All right, thank you very much.